The radioactive elements like uranium, 238, 235, thorium, 232, samarium, rubidium, potassium, whatever, are the most reliable ones for dating the rocks. At least those are used most frequently. Those are the ones we analyze for radioactive decay. I'm not dwelling on the radioactive decay. I'm just taking you through it very quickly. These are the half-lives of these elements on the regular time scale. And you notice they're very long half-lives in billions of years. That means half of the amount of stuff disappears in that amount of time. So according to radioactive decay, you never get 100% gone. It always divides in half, 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 until you got so little left that you can't detect it anymore, you see. Okay. Now, intense thermal plasma energy is operating on those radioactive elements. A magnetic energy, which contributes a lot to it too, about 29%, and the energy due to gamma emission, about 11%. All those things are going on to affect those radiation decay rates. What happens as a result of that? They get accelerated. Okay, I'm not going into the details of this. I'm going to go quickly. People who are in the know say, well, what about all these nuclei that you have that are stripped of all the electrons, are all positively charged? How come they're not just repelling each other when they, come together? And the reason is that the electrostatic repulsion is far less in energy than all the rest of the energy, the magnetic energy and the plasma energy that pushes them together. That's the reason. But look at the change. Uranium-238, 4.5 billion year half-life goes to 2 minutes. 235 goes from 0.6 billion to 13.4 minutes. Thorium-232 goes to 15.6 minutes. Samarium-147 goes from 97.7 billion. Now, the Earth is not even that old, not even the universe, right? But that's the half-life of that thing, 1.56 minutes. They all go down to minutes based on the detailed calculations, which I'm skipping, okay? I'm not giving you the detailed calculations. Now, what's happened? All those decay rates have changed. So if you're going to use radioactive measurements to, say, date the rock, date the fossil with these substances, you're already well aware, or should be well aware, that they decayed a long time ago. Okay? I mean, yes, today and today's conditions, they go back to the original times, the long times. That's because all the initial conditions have changed. See, all those energetic conditions are not there anymore, right? But still, the effects of the acceleration, let's say biblical time frame, 6,000 years ago, the origin of the Earth, roughly. Usher's dating 4004 BC or whatever. And it's about in the right neighborhood. Very, very different, okay, than it is today. Well, that's the comment made here. So the ratios were the same as they are today, but they were on a different scale because they all were equilibrated to very quick half-lives, very short half-lives.